valve design. 2,000 pulses, 0 to 2,000. It's precise control on the indoor units and outdoor. And I've got another beautiful video for you. This is an animation sequence of what the actual valve looks like. Both valves, actually. We're going to talk about the gear driven, and we're going to talk about the non-gear driven, or the donut valve, as some people call it, or linear expansion valve, as others call it. You notice you have a pulse motor, you got the rotor, the shaft. We're going to go ahead and add some slow down gears to that. And as you can see, there's a center shaft there as well. In this electronic expansion valve, they're all housed in a waterproof enclosure. As you can see, that's a bolt-on. And then we have our driver. Typically, our driver is lubricated with some kind of silicone grease to prevent moisture intrusion into the valve. This is what's twisted and turned as it operates. These are to remain in contact with each other at all times. As you can see, this is our body housing. You've got your valve needle and your bellow. Valve needle is what comes in contact with the refrigerant. Your bellow is what the separation between the two is. Think of it as a giant spring. This is an isolated and sealed valve, so you can remove the top of this valve to service and inspect it. Come to our installation and troubleshooting, or our service and troubleshooting class, we talk about how to diagnose these as well as service these. As you can see, these are all the major components when we're talking about electronic expansion valve. Now I have another video here.
Is this only for VRF equipment though?
No. This is this particular expansion valve, and if you see it in any other application, this is how it operates.
Very good.
So here's what it looks like refrigerant flow. This is what is actually happening and occurring inside this valve. And if you've purchased Craig's book or you've attended his class, you'll understand that he's actually got a great diagram, which will also cover a very dumbed down version that I created on the fly to show you exactly how we drive that expansion valve electronically. But this is essentially what we're doing. It drives down, closes off refrigerant flow, it opens up. That means that if you pull this valve off, right, it is going to open a full open. A lot of people have a misconception that when they pull this valve head off on VRF equipment, that it's closed the valve. It does not. You have now just created it to 100% open and allowed the flow to pass through unrestricted.
If replacing these, is there a torque spec that we need to pay attention to?
Yes, so it depends on the manufacturer. You can always find in the installation manual for certain components like this, or the service manual, positions as to where they want you to tighten it and direct it to, so that you're correctly, when it operates the 0 to 2,000 pulses, that it's not overshooting or undershooting. But I would recommend you to your specific manufacturer as to how they want you to install these, or the orientation of them on a particular piece of equipment. Because as you can notice, it's not centered, right? It's offset. So let's talk about the other style, the donut style, if you will, that I've heard many times. This is the style that slides over top of the actual expansion valve. This is the one that Craig has a great illustration in his book, and they spent a lot of time creating some great pictures to actually understand how this operates and how it functions. As you can see, we have two different motors, one on top and one on bottom, 4 separate windings with the teeth inside. I didn't realize how slow this video is going to talk about.
It is slow.
This is the magnet rotor in the center, right? Now notice, there are different sizes of valves like this. There is the 480 pulse, there is the 0 to 3,000 pulse, there is the 0 to 6,000 pulse. So you'll notice that they look slightly different. You also find these on your mini splits, your 1-to-1s and your multi-splits. You'll find this on some unitary equipment. Trane has been using them for a while, right? Carrier has 2, they're starting to implement it in some of their higher tier equipment. We've been using them since the dawn of time on all of our equipment. But this is how they operate. It's essentially the same principle, but the thing to remember with these particular types of valves is that when we're servicing them or we're maintaining them, that you're going to want to remove the valve body top, right, off, and clean the housing. Rust gets in between them. You'll notice the other one, there's nothing exposed to the weather elements. With this particular type here, if it's not correctly covered, you'll have to go in and do maintenance on it. Otherwise, rust builds up between the outside casing and actually interferes with the magnetic resistance inside the valve, and you won't actually drive the valve like it's supposed to. It'll send the pulses for 480 pulses to open, and it actually only gets 240 pulses of movement because of the rust. That's essentially what it's doing. It's spinning away on the inside based upon the drivers on the indoor PCB, on the outdoor PCB, whatever's trying to control it. And as you can see, the inside spins as well, and this is how we meter our refrigerant flow. We'll add animation to that and show you exactly which way the refrigerant flows. There are manual magnetic donuts that you can purchase from your specific manufacturer to manually drive these. But there's also a tool that I've used out in the field that I found extremely helpful, which is the EEV Make tool that can actually allow you to manually drive these using an electronic device in your hand. Now, I tell people I use caution with that you need to understand how they operate and the valve that you're working on before you use a tool like that, because you don't want to overdrive it or underdrive it and get it stuck somewhere where it's not supposed to be. Right? Every manufacturer drives their valves differently when the unit's turned on and off, how it's power cycle, stuff like that. So we just want to make sure that when you use a tool like that or use any tool like that, you want to ensure that you're following the proper procedures according to that manufacturer. And you're not actually breaking the equipment. All right.